Okay, hey everyone. So today we're talking about matter and transformations. So a little preview of what the topics we're going to cover today. We're going to be talking about classification of matter. So we already talked about in the last unit, explained that all matter is made of atoms. Atoms are made of protons, neutrons, electrons. We already talked all about that. And we understand that the number of protons in the nucleus defines an atom as a specific type of element. Today we're going to classify and identify matter as pure substances, mixtures, homogeneous or heterogeneous. So we'll talk all about that. We'll also talk about the physical and chemical properties of matter, or really actually what a chemical property is, what a physical property is, some examples, and how do we determine it's a physical change or chemical change. It's a little tricky, honestly. Physical chemical change is a little tricky, and it takes a while to really understand which is which. But actually, a lot of the lesson today is really just on classifying and identifying matter. As we go through today, there's going to be quite a bit of writing, but you should be writing everything in blue, and I'm going to have that reminder. So you see that up here. It says you must write everything in blue. Other items are optional. Yeah, so do write everything in blue. The other stuff, that's up to you how you wanna cover it, how you wanna what you wanna write, what you don't wanna write. All right. So let's get started here. So what is matter? What is matter? So there's quite a bit to write here on the side here in blue. If you want to take a second and pause the video, you can pause the video and write this down. All right. After you pause the video, then you can listen to what I have to say. It's sometimes if you write you don't listen. So it's better to write first and then listen later. All right. So let's go through this. Hopefully you pause it and now let's go through this. So anything that has volume and mass is considered matter. So volume is the space an object occupies. So it has to take up space. And mass is an object's resistance to change and acceleration. I know that's kind of the physics definition here, resistance to change and acceleration. But really, you could think about it, it's just the amount of matter something is made out of. It's very, very, very closely related to weight. And as far as we're concerned on Earth, mass and weight are the same thing. Mass and weight really don't change here on Earth. Mass and weight are the same when we're on Earth. It does change if we go to other planets. So the mass never changes from one celestial body to another. So if we go on the moon, we still have the same mass, but we're going to have a different weight because weight is the effect of gravity on an object. Okay, but mass is just pure the object's resistance to change and acceleration. So the more massive something is, the more it resists acceleration. So it's harder to get it going faster or even to get it going slower. It's harder to change its motion. All right. And all matter is made of building blocks called atoms. So everything is made of atoms. Everything, all matter is made of atoms. All right. This is a kind of a flow diagram here. We're going to look at this more closely in a second here. But matter, yeah, we'll look at that in a second. Let's go here. So let's talk about atoms. So atoms, we just finished unit on atoms. This year we finished unit atoms. Maybe in the future. Sometimes I go back and forth. Sometimes I teach atoms first. Sometimes I teach matter first. It really doesn't matter. Well, it does matter. Everything's matter, but except energy. But yeah. Anyway, so we should know this already. So I don't have you writing this down. Atoms are the smallest building blocks of matter that have unique properties. So they're organized by the number of protons in the nucleus. So hopefully you got that from last chapter. Hopefully you understand that the number of protons determines an atom. So every atom with one proton is called hydrogen. Every atom with 6 protons is called carbon. Every atom with 8 protons is called oxygen. And we list them all on the periodic table, right? And this periodic table that we're looking at here actually has pictures of the different elements, as best they can, pictures of what they actually look like in real life, right? So hydrogen is actually an invisible gas, but most of the universe is made of hydrogen. It's the most abundant element in the universe. This is the 3 pillars. This is I forget what it's called. It's a galaxy somewhere off in the distance. It's called 3 pillars. I know that. But as you'll see, like a lot of these elements are just gray and metallic. Most of these are gray and metallic. Metals are on this side of the periodic table, and non-metals on the right side. We'll talk more about that in the next unit. But so atoms make up all matter in the universe, everywhere. Okay. A little disclaimer here. So you learn that all matter is made of atoms. Atoms are considered the smallest building blocks of matter, but that's actually not really the case. So I think you're old enough now to understand that, sometimes we simplify things. Scientists simplify things all the time. So scientists simplify it, say, oh yeah, all matter is made of atoms. And it is. It is made of atoms. And they're the smallest building blocks of matter in some, in some kind of way. They, they are like the Legos, the Legos of the universe, right? The Legos of the, we talked about last unit, the Legos of the universe. They all click together to make everything. But atoms themselves are actually made of protons, neutrons, and electrons. They all have mass and occupy space. So technically protons, neutrons, and electrons are all mass. Okay. And they are matter, they are all matter themselves. And those subatomic particles are even made of smaller particles called quarks. So they're even smaller, and those things have mass and volume. And there's smaller particles than that. And it goes on and on until we, it gets more and more difficult, more and more tricky. But basically, atoms are the building blocks of matter that we're really concerned with. They're the only ones that really matter right now. Okay? So let's just keep it at that. And I just want to let you know that because I don't want to you to find out later, oh, atoms, there's things smaller than atoms. Well, yeah, telling you the truth. Just as far as you're concerned, that's all we need to know about is atoms. We don't need to know about quarks or anything like that, right? All right, so classifying matter. Now, this is a very important diagram here. So you definitely want to pause the video for a second, and write all this down. I'm really not going to take a long time to stare at this in my video. So pause the video, write this down. Okay, draw it exactly like it is here. Maybe leave a little bit more space to write some notes here. Okay, because I'm going to talk about each one of these things individually. I'm going to actually break it down to left side and right side. Okay, so we're going to look at matter, occupies space, and has mass. That can be broken down into a pure substance. So a pure substance is matter that cannot be physically separated. It can be broken up to a mixture. Mixtures are substances that can be physically separated. Things like filtration, distillation, or other physical means. Just like you can think of your cereal. You could look at cereal and you can separate all the little pieces. If you have so if you have all little nuts and berries in your cereal, you can separate the nuts and berries out. So things like that. If we have pure substances, we can have an element, so a single type of atom. So, for example, helium, or we can have a compound like H2O, like water. For mixtures, we can have homogeneous mixtures. Homogeneous mixtures, they look the same throughout. For example, like salt water. You can't see the salt in water, but it is a mixture of salt and water, NaCl and H2O. Or we can have heterogeneous mixtures, things like where you can see the different parts, like trail mix or cereal. Those are two good examples. All right, so we're going to go through all that. Ready? Let's do it. Okay, so first one, pure substance. So again, this was matter down to pure substance. And now here we go, pure substance, matter that cannot be physically separated. Okay, so we cannot separate, each helium atom, we really can't separate them individually. It's really hard to do that. But we have a single type of atom, and we can't separate one helium atom. We can't physically break it apart. And that's kind of true, but yeah. One helium atom, we cannot really break apart the protons, neutrons, and electrons. Okay, not by any easy means. Okay, we can use a Large Hadron Collider to break it apart, but it's very, very hard to do and not very likely. Okay, so we can't break these apart by any physical means. All right, and then a compound. So a compound is when atoms are chemically combined, so like H2O, which is water. We have carbon dioxide, which is a carbon and 2 oxygens. We have methane, which is a carbon and 4 hydrogens. We have ammonia, which is a nitrogen and 3 hydrogens. So these are things are compounds. These are chemical compounds that cannot be separated by any physical means whatsoever. We'd have to undergo like chemical reactions in order to separate these things. All right, so again, pure substances, they cannot be physically separated, okay, not by any easy means. All right. And then we have mixtures. So mixtures can be physically separated by filtration, distillation, or other physical means. All right, homogeneous. So yes, homo is a prefix in science. Homo means the same. So homogeneous means it looks the same throughout. Okay, so homogeneous, just like homosexual means the same sex. Homogeneous means looking the same throughout. Okay, so you see only one thing. You can't see the different things. So coffee, you can't see the sugar and the water and the coffee extracts, like the caffeine. You can't see any of it in the coffee. Wine just looks like one pure substance, but it actually is a homogeneous mixture. Things like brass. So we actually made those pennies. Remember those golden pennies? Well, those golden pennies were actually brass. Okay, it's actually a mixture of zinc and copper. It's a homogeneous mixture. You can't see the different parts. You cannot see the different parts. Okay, heterogeneous means different. So we can see the different parts. So heterosexual, different sexes. Okay, so heterogeneous, mixture that we can see the different parts. So like chocolate chip cookies, trail mix, pizza, soda with ice. You can see the ice in the soda, a salad. You see the different parts of the salad. So all those things are heterogeneous mixtures. Okay, so homogeneous versus heterogeneous mixtures. Next. Okay, physical versus chemical properties. These are often difficult. Physical and chemical properties I always find tricky because chemical change requires the matter to change. So it requires really to have the compound. So when we talk about a chemical change, we're talking about the compound changing. Okay, so we're talking about the compounds changing. All right, so we're having a change in the atoms that are connected with one another. Okay, whereas a physical change, a physical property, is we're keeping the chemical the same, the element the same, but we're changing something else about it. Okay, we're changing its texture, its color. Well, actually, color is a physical property, but changing color is a chemical change. It gets tricky. All right, so let me just make this simple. All right, physical properties, they can be observed without changing the composition of matter. Okay, so physical properties, we can observe them or measure them without changing the composition of matter. So we can look at the color, we won't change the color of it, but we can look at it. We can look at malleability, conductivity, ductility, melting point, solubility, boiling point, density, the state of matter. All of those things are physical properties. Okay, so what are these things? So let's talk about malleability. Malleability is how easily can it bend? Can it bend or be like molded? So I always associate malleability with moldability. Okay, think of like clay. Clay is very malleable. You can take clay and you can mold it into anything you want it to be. Okay, and metals are typically pretty malleable. Metals are malleable, meaning they can bend. They bend without breaking. Okay. Sorry, I'm turning my fan on here. So they bend without breaking. Okay, it's also this little hammer. That's it being malleable too. You hit a hammer to a piece of metal and it molds it into something different. Mold it into something else. All right. Density. Density is the mass per volume. So the mass per volume. How much mass in a given volume? Boiling point. Boiling point is the temperature at which it turns from a liquid to a gas. Conductivity. Conductivity is how well it conducts electricity or heat. So we use that word conductivity for both heat and electricity. Ductility. Ductility is always one that a lot of students don't know, but it's how easily can you turn it into wires. That's why the wires picture is here. So can you make it into wires? Okay, and the reason they use the term ductility, duct is a passageway, D-U-C-T, is a passageway for something. So there was the aqueducts in Rome. Aqua is water, duct, water passageway. So aqueduct, water passageway. There's duct work in a lot of houses on the mainland, not so much here in Hawaii, but ducts in your house, they allow passageways for air. Well, a wire, what is a wire a passageway for? A wire is a passageway for electricity. So we call it ductility. Ductility. Like electricity, ductility. Right? Melting point. Melting point is the temperature at which something goes from a solid to a liquid. Solid to a liquid. And then solubility is, does it dissolve in water? Sometimes we also can say solubility for other things too. Does it dissolve in methane? Does it dissolve in other substances? So solubility is used mostly for water, but for other things too. All right, and then the states of matter, so solid, liquid, or gas. Those are all physical properties. Physical properties. All right. Chemical properties totally has to do with how a substance will react with other substances. Okay, so is it flammable? Is it toxic? Is it acidic? Is it reactive? Does it give off heat, or does it take in heat when it reacts with other substances? All right, and it really answers the question: how does this compound react? How is this compound likely to react? Okay, there's some keywords here, and I'll put a list of keywords at the end of this, and I'll just leave it up, and you guys can write down some of the keywords. I think that's the easiest way to tell if something is a physical or chemical change in terms of like words is looking for keywords. So keywords like rust, corrode, ferment, explode, rot, burn, precipitate, react, oxidize. Those are all things that are chemical changes. Explode actually could be both physical or chemical. You really have to think, is it changing a new substance, or is it just breaking up into smaller pieces? You really got to think about that one. But these other words always indicate chemical changes. Okay. Next, physical versus chemical changes. So physical changes do not change the composition of a substance, as I said. Okay. Some indicators that a physical change has occurred. You'll get a phase change due to heating or cooling. So you heat something up or you cool it down, it goes from solid to liquid or liquid to gas, one or the other, goes from solid all the way to gas. That is just a pure physical change. Okay? And then if you physically break apart or grind something, that is all physical changes. So physical changes, you're not having it react with anything. It's just something you're doing to it physically. You can separate it, but you don't necessarily need to write this down, because what I think is the best thing to do is identify whether it's a chemical change. If it's a chemical change, then it's not a physical change. If it is not a chemical change, then it is a physical change. So you just got to really remember, all right, what are the indicators of a chemical reaction? So these things, if these things happen, then it's a chemical reaction, a chemical change. So if the color changes without mixing it, like if you take two paints, like if you take blue and yellow and you mix them, you get green. Okay, that is not a chemical change, because you're just mixing the colors together. Okay, I'm talking about if you're doing a reaction and a color change occurs. So you're not the two colors that you get, like you mix two colors and you get a new color. That's not the same thing as if you mix two things and then a color change happens. You get a new color altogether. So going back, like if you look at the even like the penny here, this penny is turning from bronze to green. Well, bronze can't mix with anything to get green. Okay, that's an indicator of a chemical change. This one, you're mixing two liquids together. I know it's not like a video, but you're mixing two clear liquids together and you're getting a yellow substance. That is a color change. There was no other color before, and you just get a new color. Okay, so if you get a new color that is not a result of mixing, then that indicates a color change. Okay, we're going to do a lab on this, and you'll see. We'll do a lab when I get back. Okay, production of light. So if any reaction produces light or produces heat, or it gets colder or hotter, and you're not heating or cooling it, so kind of like number 2 and 3 are together here. So temperature change without heating it or cooling it. So you're not heating it or cooling it, you're not putting it on a flame, you're not doing anything to it, and you mix two things together and it gets hot or produces light, that is an indicator of a chemical change. Okay, if it produces heat or light. Next, if you get a production of a gas. So if all of a sudden you get gas, so if you mix like vinegar and baking soda together, you get a gas. That is an indicator of a chemical reaction. Okay, production of a gas. Okay. The next one is formation of a precipitate. So this is when a solid forms within a liquid. So this is actually an example right here. This little test tube. This test tube has some liquid in it, and then you pour other liquid into it, and as you pour the liquid, it turns solid. There's a solid yellow substance forming in it. Okay, and that is called a precipitate. Okay, so when a solid forms in a liquid. Okay, and then the last one is change in smell or taste. This is very similar to production of gas, because the smell or taste change would be kind of production of something else, a production of a gas. So change in smell or taste. Probably the best example of this is your milk. If you leave your milk in the refrigerator for too long, or really any food, you leave any food in the refrigerator for too long, and it starts to smell or taste different. And that's an indicator that there's a chemical reaction going on there, and the food is changing from one form to another, and you don't want to eat it anymore. Okay, and that's usually occurring because some bacteria in there is changing it and eating it. Okay. Okay. And then, as I said, here is a list of all the words that kind of indicate chemical and physical changes. So physical changes, things like boiling, breaking, chopping, condensation, crumpling, crushing, cutting, dissolving. Ductility, that's a physical property. Dyeing, so like absorbing the dye is a physical change, where dyeing, if the fabric is dyed, like if it changes its properties, then it could be a chemical change. So that's a tricky one. Like looking at it is a tricky one with a color change. Definitely hard. Evaporation, freezing, grading, liquefy, malleability, melting, mixing, mowing, like cutting the grass, reshaping, shredding, squeezing, stretching, sublimation. Sublimation is going directly from a solid to a gas. That's what CO2 does. If anyone's ever seen dry ice before, that's what it's doing, subliming. Vaporization, wrinkling. Okay, chemical changes, things like baking, bleaching, bubbling, burning, combusting, cooking, corroding, decomposing, digesting, endothermic reaction, exothermic reaction, explosion, fermenting, fizzing, frying, grilling, molding, oxidizing, photosynthesizing, production of odor, rotting, rustling, or souring, tarnishing. Those are all examples of chemical changes, or words that would indicate chemical changes. Okay? And distinguishing between chemical changes and physical changes is actually pretty difficult. So pause for a second, and you should write some of these words down. I don't know if you need to write all of them. If some of them are new to you, I would write those down. Just kind of know what they are. All right, because next thing we're going to do, so we're going to go to this worksheet. Okay, so on this worksheet, the first thing you're going to do is you're going to look at each material. And if you're not sure, that's okay. Give your best guess. That's what really counts here, is giving your best guess. Okay, you're going to pick, is this a pure substance or mixture? So that's the first thing. So concrete, I'll give you a little hint. Concrete is a mixture. So you're going to write mixture. So concrete is a mixture. And then if it's a mixture, it's either homogeneous or heterogeneous. So concrete, and this one's a tough one. It really depends on the type of concrete, but I would say we could see probably the little pebbles in it. So I would say heterogeneous. And you can just write hetero. Okay, so you're going to write hetero, right? So that would be how you do this worksheet. If it's a pure substance, then you're going to pick between whether it's an element or compound. Okay, so mixture would be either homogeneous or heterogeneous. Pure substance would be either element or compound. So let me see here. So like iron filings is a pure substance. Oh, pure substance. And is it an element or a compound? Well, it is an element. It's a pure element. Okay? So the top one, pure substance, only you would pick between element and compound. And then mixture, if you pick mixture, then you would pick homogeneous or heterogeneous. All right? A little bit tricky, but I think you guys can handle that. Okay? On the back here, you're going to look at the prompt and tell me whether you think it's physical or chemical. Physical or chemical. All right, so boil would be physical. You're going from a liquid to a gas. All right? Same thing here, like mending a broken bone. That one's tricky. I would say that's more physical than anything. But I would definitely say there's some chemical changes that occur there as well. But because we're making, I don't know, like you could argue this. Like I used to have here a little like another place, and you'd have to explain to me why you think it's physical or chemical. But I found that students really didn't write enough there to make it worthwhile. So when we do go over the answers to this, oftentimes I will tell students, argue with me. Tell me why you think it is. Okay? Tell me why you think it's physical. Tell me why you think it's chemical. All right, and most of the time on quizzes or tests, I make it really, really obvious whether it's a physical or chemical change. I don't try and trick you because these are tricky. Okay, and having the conversation is probably more important than anything. Like understanding how to tell me whether it's physical or chemical. Well, chemical means that it is changing what it's made out of. It's changing the compound. It's changing the substance. Okay, and sometimes that's hard to know whether it is or not. Okay, so it's tricky. It is tricky. All right, so you just do that as best you can. You can definitely get some wrong. That's okay. Don't like freak out if you get things wrong here. Just try and make sure you can like argue why you think it is what it is. All right, and then the last one down here. What are the 5 indicators of a chemical reaction? I know in my slides I have it as 6, because sometimes like I combine production of gas and change in smell or taste. Sometimes we combine those two. And sometimes some people combine these two, production of light or temperature change. They just combine them into energy is heat is released or absorbed. Okay, so I mean, write all 6. Go ahead and write all 6, just how it is here in this right here. Okay, and that's it for today.